Hello, I'm Moreno Dinka, and in this video I will present our work titled OpenBias, Open Set Bias Detection in Text-to-Image Generative Models. It is well known that deep learning models learn underlying biases present in the training set, and generative models are no exception. We can observe this behavior in this example, where we generate 8 images showing how a gender-neutral prompt, such as a picture of a doctor, yields all males because of the doctor's context. This issue motivates bias mitigation research. However, existing studies focus on a predefined set of biases, such as gender, race, and age. While these represent perhaps the most sensitive biases, we argue that other biases remain undiscovered and unstudied. Therefore, a closed-set formulation to bias detection is suboptimal. Consequently, the core research question of this paper is, can we move to an open-set scenario to discover unknown biases without predefining them? Let's now better understand the difference between closed-set and open-set settings. The closed-set formulation begins from a given prompt and the target generative model under study. After generating a set of images, a specific bias is assessed. This step has two major requirements: a predefined set of biases and a bias-specific classifier to detect each bias. These requirements make this setting closed set, as they prevent the discovery of novel biases. In OpenBias, we address this problem in an open set fashion. Starting from the same prompt and generated images, we design a bias proposal module that can propose biases without needing to predefine them. Next, we assess the presence of the proposed biases using vision question answering, removing the need for a domain-specific classifier for each bias. This approach is open set, as it does not rely on a predefined list of biases, and it does not require bias-specific classifiers for assessing the biases. OpenBias consists of two core modules, the bias proposal module and the bias assessment module. Let's now see how this pipeline works. We start with a dataset of captions T as input to the bias proposal module. This module leverages in-context learning applied to a large language model to propose biases for each caption. By doing so, we build a knowledge base of biases B without requiring to predefine them. Let's take a closer look at one specific bias, for example, person race, to understand the information it holds. This sub-B represents caption-specific information, which is composed of the original captions and a set of generated questions by the LLM. The final piece of information is a set of classes, C sub B, general to the bias, which will be useful for representing and assessing the bias. The associated captions are then fed to the target generative model G for image generation. At this point, the generated images, questions, and classes are fed into a vision question answering model to assess the presence of the bias. The final output distribution from this module can be used to rank the specific biases. We use an entropy-based scoring method for this step. This pipeline is thus capable of proposing and assessing biases without predefining them. OpenBias uncovers novel biases related to people, objects, and animals. We show examples of biases discovered on Stable Diffusion Excel. We can observe how well-known biases such as gender and race are also reflected in children. For instance, the generative model exhibits gender bias when asked to generate a child in a baseball context. Similarly, an ethnicity bias is detected when an economically disadvantaged environment is described in the caption as a dirt road. We also detect biases related to objects and animals. For instance, Stable Diffusion Excel predominantly generates rain as yellow or laptops as MacBooks. Additionally, we present qualitative results on the well-studied and sensitive biases of gender, race, and age. Finally, we showed a ranking example of the discovered biases using captions from the Flickr 30 dataset. Bias ranking enhances model analysis and comparisons, helping to understand the behavior of different models. In conclusion, we shifted from closed-set bias detection by presenting OpenBias, a novel pipeline tailored to the novel task of open-set bias detection. The pipeline leverages foundation models to propose, assess, and rank biases. OpenBias discovers well-known biases as well as novel biases, showing the importance of open-set bias detection. Thank you for the attention.